Okay, hello everyone, my name is Athur Huillet and I'm going to explain to you how a role-playing game is written. So I'm going to speak about Friedrich RPG, which is a game that I know very well because I'm the lead developer and I have been for 7 years. First of all, I'm going to show you the game so that you get a good grasp of what exactly we are talking about. And then I'm going to explain the software architecture of Friedrich RPG, what are the big components, and what are the big things that you have to write if you do a game like this. Then I'm going to be a bit more technical because I want to explain a few of the good decisions that we made, and also I will show a bad decision that we made. I will explain why it was a problem and why it's difficult to fix a few years after the decision was made. And okay, let's start with the game. So Friedrich RPG, this is a game that tells the story of a world destroyed by conflict between robots and their former masters. We are in the year 2154, and the humans have been building a lot of robots to help them around with many things in life. And all of those robots were built by a monopoly company, and they were using a proprietary operating system. So there were a lot of security problems, and one day something happened, and the robots started destroying everything. So your player wakes up in the middle of this world, and you have to understand what's going on and try to help. Now, technically, this is an isometric 3D role-playing game. We mix real-time action, so similar to Diablo, for those who know it. You can fight the robots with many different ways, and we have role-playing, which we do through dialogues. So you have to talk to a character, the character tells you something, and you have to click a choice of options for what your character is going to say, and this makes you able to choose really what path you want to play. In terms of simple facts, the game is fully playable and has been for about 4 or 5 years. We work on as many platforms as we can. It will give you a good full weekend of entertainment, perhaps more. It depends how many of the side quests you want to do. We have a lot of characters, and we try to have very rich dialogues, so you have a lot to read, you have a lot to say, and you can replay the game and choose different options, and it will be a bit of a different game. We've got original music, and our download statistics will make some of you smile because it's not huge, but on the other hand, it's also, we believe, the symbol of a significant audience. We don't have. We're not one of the biggest role-playing, one of the biggest free software games, but we are amongst the biggest role-playing games in the free software world. So I've prepared a small demo video. It's going to be a bit redundant for those who were here the last quarter, but never mind. Okay, this video was made a few years ago when I gave a presentation at FOSDEM 2009. It shows most of the features of the game. So this is a mini game that you can use that will turn the enemies on your side, so you can use it to hack robots and they will fight for you. You have some pretty stupid options. You can say, I'm here to assassinate your leader, and your game will end pretty quickly after that. If you pick the wrong option, you can get to game over very quickly. And we have a set of skills. You can repair your items. You can run viruses on enemy droids. Most people here are familiar with this kind of gameplay. You have a set of statistics that you can increase when you get a new level. So you kill bots, you get experience points, and this gives you the ability to improve your character in certain areas. Okay, you've seen the game. Now, our goals as a game project. The first one is that we want to be enjoyable by everyone. So this means that we want the game to be rich enough to be entertaining to adults, but we also want the game to be playable by children, which we do with a very distinctive graphic style, which naturally gets children interested in the game. But this is not strictly a kids' game. We want to work on as many of the machines out there, so this goes from your computer that you had 15 years ago to what you have now. And we are definitely a single-player game. We don't have plans for multiplayer right now. We really want to cater to single players. Now, a quick history of the project. So the game was started in 2002. I took charge in 2004. And we introduced translations because we have a significant volume of dialogue, so we've got a lot of text. We decided to introduce translations in order to widen our audience in 2007, and it was not a very good idea because it was too early. So in 2009 I gave a first presentation here, and at the end of the year we noticed that the translations were too much of a maintenance burden because the dialogues were changing too much. So we had to remove them, and we have not put them back as of yet. And this is perhaps the biggest problem with FOSDEM RPG today is that if you do not read English, you cannot play it. We had our first Google Summer of Code experience with 3 students 2 years ago. And right after it, we made a new release to integrate all the work of those students. So we went from a team of about 5 people to a team of 10, but then it's free software, it depends on the availability of everyone. So at any given point in time, we're like 3 people active. We took part in Google Summer of Code again last year, so this time we had 4 students. This time we made a lot of improvements to work on the new platforms. So the graphical user interface refactoring was useful because up to now, FOSDEM RPG was only playable on screens that had a ratio of 4:3, which was the case 10 years ago. All of the screens were 4:3, but now this is 16:10, and most of the computers today have very special ratios. So we were unable to present our graphical user interface correctly. It was completely distorted. So this was the work. This was the main point of the work of this summer. And we made a release recently to integrate all of those changes. Okay, so you know what the game is. Now I'm going to explain how it's written, how it's built. So the first thing I want to talk about is the game world. All video games are about the simulation of a virtual world. Now you have seen the world. And the first thing that you need to simulate a world like this is a way to locate objects in this world. So you need a coordinate system. In an isometric role-playing game, you have this typical coordinate system. And you will use it to locate all of the elements. The first object that FOSDEM RPG uses are the floor tiles. The floor tiles are purely graphical elements. They are the decorations on the floor, but they do not have a physical presence in the virtual world. So each of the squares that you see here on the checkerboard represents one floor tile, and the floor is completely covered with them to decorate the rooms. Now we have a second kind of object, which is obstacles. Obstacles, they are the elements in the game that have the ability to block the way from one point to another. So they have graphics and they have a physical presence, which the floor tiles don't have. They occupy a volume. We have defined, I don't show it here, but we have defined what we call a collision rectangle, which is the space on the ground that is blocked by the obstacle. The obstacles are unable to move, but they can react to external action. So for example, this is a door, and when I get close to it, it will automatically open. All you can see here are obstacles, so you have walls, but you also have all the furniture. here you can see the floor tiles and the obstacles. So this is the base world. And on top of that, we add the notion of actors. An actor is simply an element which has graphics, a physical presence, and the ability to initiate actions in the world. So you have the player here and two artificial intelligence characters. They have the ability to move, they have the ability to attack, they can initiate dialogues, they can interact with obstacles. For example, you can connect to a computer terminal, and so on. So this is what actors are for. And now we have a lot more small elements which are not very relevant here. So for example, we have bullets, because they're not really an actor, they're not really an obstacle. We have bullets, we handle explosions separately. We've got dropped items, so when you kill a character, it will drop what it's wearing. So you have items on the ground that you can then pick up. And we have events. So events are not visible. They are the only elements that I'm introducing here, which does not have graphics. The events, they are, for example, here I can place an event trigger, which means that when I will walk on this floor tile, it will do something. It will trigger a piece of script. So for example, you can use it to do traps. You walk in a room, you walk on the floor tile which has the event, and it closes the door behind you. And with all those elements, you have the main things that can enable you to do free-to-play RPG. Now, let's take a wider look and see what are the big modules, what are the big parts that make free-to-play RPG. I've laid them out in three categories. The first one are what I call the action modules. We have three ways of acting. Those are the pieces of code that do something on the virtual world. So the first thing is the user input. Quite obviously, you have to read the mouse, you have to read the keyboard, and you can use that. For example, I've clicked there, my character will go there. This is the first kind of action that you can do. The second is the artificial intelligence. This is what drives all of the actors which are not the player. This is a finite state automaton that makes the decision and moves around and attacks and so on. And we have a scripting interface which is used, as I've said, for example, for events. So it's a third way which is a bit less obvious to interact with the engine. You can create obstacles, you can delete obstacles, you can spawn new robots, you can change just whatever you want with the scripting interface. Now, you have the ways of acting upon the world. Now, the world itself has several categories. The first one are what I call the gameplay rules. You do not see the rules. The rules, they are implemented, but they are a way to put into numbers a set of rules that simulate the world. So, for example, we have, when you attack a character, you strike and you may hit or you may miss depending on what kind of armor is wearing, what kind of item you have yourself. So we have a set of rules that decides whether when you strike you hit or not. So you roll a dice and you compare the values. We have an experience points mechanism. So when you kill enough enemies, when you do enough quests, when you talk to someone and manage to get him to do something that he didn't want to do, you are awarded experience points. When you have enough experience points, you get a new level. And when you get a new level, you gain the ability to improve your character in some way. We have, for example, damage rules, which decide how much damage you deal, because in a virtual world like this, you need numbers for everything. So we have the notion of health points. All of the actors have health points. The health points are a number, and when you get to 0, you're dead. So you have to decide how many health points you remove every time something happens. This builds all the main rules that we use. And now you have some physical simulation. So physics are what I've shown just before. This is where you define the notion of actors, of obstacles, and so on. What you need, first of all, is the ability for the actors to move around. So this is code that says that makes the decisions to move to some place based on coordinates and so on. And to move, you need to know what path you're going to take, because you have a set of obstacles, then you have actors, and you want to decide what way you will take. So for this, you need pathfinding, and the primitive of pathfinding, the thing we base upon, is collision detection. I'm going to go back on that later, because we have problems in free-to-play RPG with pathfinding and collision detection due to some bad design decisions, so I'm going to explain in detail why we're not happy with it. And finally, we've got some some kind of satellite modules. They are very important in the game itself, but for the purpose of this talk, I don't think they're so relevant. Basically, those are dialogues. So the dialogue engine itself is very big. I don't know how big exactly, but it's about 10,000 lines of code because we have a very complex notion of nodes which trigger other nodes, and so the dialogue is a big thing, but in the main architecture of the game, it's not so important. We have shops, so you can get items and you can sell them to the people you meet. And we have events, which I've talked about already. And finally, when you have simulated the world, you have the ability to act upon it. You need to display it. You need to present it to the user. So what you present are two things. You present a 3D world, which is the virtual world that you're simulating, and you present some user interface pieces which are useful. For example, those are the buttons you can click to open up the inventory and so on. And all of this is based on what I call a draw module, which, to be more technical, is a way to abstract the rendering API that we use. Because since we want to work on as many platforms as possible, we need to have the ability to target OpenGL on the machines that can do it. But if you have a laptop that cannot do OpenGL, if you have an old machine with no free software OpenGL drivers, we also want you to be able to play the game. So we have an SDL rendering mode which uses the CPU. It doesn't look as good and it's slightly slower. It consumes also much more power, but at least the game works. So this is the full graph of the modules of FOSDEM RPG. Now, I've just talked about it. We really care about you being able to play the game on whatever machine that you have, except a few mobile platforms, but this is another topic. So we have to provide you with a way of playing the game, and from the ground up we had this kind of dual OpenGL and SDL support, but it was done in such a way that it was very painful to maintain. So 2 years ago I set out to rewrite this. I destroyed all of the rendering code in FOSDEM RPG and I rewrote it with an API that completely abstracts the notion of whether you're using SDL or OpenGL. So we manipulate what we call images, because we use OpenGL, but this is not a 3D game. We draw exclusively pre-rendered sprites. So this is an example. Okay, here you have obstacles. So this is one of my obstacles. This is what I draw. I draw a quad with a texture on it, and this is all we do. So we have the ability to do this both in OpenGL and SDL with very good performance in OpenGL. So this is an example of a texture atlas. The way it works is that you put all of your obstacles on a single image, you upload that to a graphics card, and you set it, and you set this as a texture, as one texture. And then when you draw elements, so for example, if I want to draw a quad made up of this wall and this wall, I will just have to pick from the same texture. And in OpenGL, this is how you get a lot of efficiency, especially on Intel GPUs, like on this laptop. When we did this trick to upload all of the elements as a single texture, we gained perhaps a 15 factor in terms of performance. So this is really something you cannot avoid.
You can do the same thing in SDL too.
We can probably, but SDL is going to render with the CPU, and in the end you don't make use of the GPU, so it's not interesting. We can do the same thing, but this trick is not interesting in SDL.
Well, SDL does use 2D acceleration if it's available, and then it keeps the image in the graphical memory, so it is slightly...
Yeah, it is, but it's much less efficient than OpenGL directly. The difference is perhaps 4 or 5 factor in terms of performance, and you get your CPU to 100%. So really using OpenGL directly is very interesting, even for this kind of operation, which I admit should be done with SDL entirely. We decided a few years ago to integrate a scripting language called Lua. Lua is well known in the world of video games because it's used by many games, including commercial games such as World of Warcraft. And we decided to use it because, hey, if everyone is doing it, it must be good. And sometimes this kind of reasoning is not true, but this time it was. Lua, is very easy to integrate in C. Here you have a few functions that we have in C, And each of those functions are called directly by the Lua scripts. And the average size of a function like this is about 12 lines of C. So this means that we have an engine written in C, and we can export Lua bindings very, very easily. So when we have to add something, when we have to do new things in Lua, it's very simple. So this means that the Lua interface became very powerful very quickly, thanks to the easiness of integrating Lua with C. And when we decided to do this, you also gain another advantage, is that when you use Lua for your config files, for your dialogues, for your scripts, you don't have to write a parser, because writing a parser seems easy, and it seems easy until you make a new decision that makes it very difficult. So in this case, we just have to use Lua, and it's very, very good. Finally, we have an internal save game mechanism, because the engine is written in C. When you're in C, you have no way of listing the contents of a structure, so you have to do it by hand. You have to write the code by hand. What we have actually is a bit of Python script which parses the definition of the structures and outputs code like this, like read underscore name of the structure and write. So it does the saving of the game practically automatically. Now, I'd like to keep some time to talk about one problem that we have in FOSDEM. We decided to make use of a continuous coordinate system for obstacles and actors. First, I'm going to explain how collision detection should be done, and then I'm going to explain what we do in FOSDEM and why it's not so good. So, this is a representation of a grid, of an isometric grid, where you see the player here on the square, and here you have the wall. You have a bunch of obstacles that are laid out in this position. So the light gray squares are the floor, and this is the wall, and this is the player. Now, we want to answer a simple question, which is the collision detection question. In FOSDEM, it is defined as follows. I am located at point A, I want to go to point B, is there a direct path? A direct path means, basically, is there an obstacle on this line? Once you have this, you can build pathfinding, because once you have this, the base pathfinding algorithm is, okay, is there a collision here? Yes, there is, so I have to move to a neighbor position, and I check if there is a collision, and so on until I find a path. So the collision detection, in this case, in case you have a grid like this, it's very easy to do. Simply, your line will look like this, so you will browse all of the elements that are intersected by the line, and for each of them, you will check whether there's an obstacle on them or not. That's pretty easy. You check the first one, you check the second one, and now you see that there is a wall, so there is a collision. So the answer to the question, is there a direct path between A and B, in this case, was no. And it's very easy to do. Now, what's interesting is when you get to floating point coordinates, when you get to obstacles of arbitrary size, you do a lot of continuous math, you do a lot of geometry, and it's much more difficult. Here, you do not have any kind of simplification that is possible. So you have the line, you have the obstacles with here and here sizes which you do not know and which are floating points. So you cannot lay out a grid. And the position here is a point. While before, you had your actor that basically took up the whole square. Now it's really a point in the math sense. So the only thing you can do is do a lot of vector math to decide whether there is a collision. You will also find exactly where it is. Even though you don't care, you will find where it is. But you end up doing a lot of floating point math to get an answer to something that should have been easy. And this is what we do in FOSDEM. So the big thing that you have to see here is that the collision detection gets much more complicated, but also the pathfinding gets much more complicated, because when you are on a grid, you go to what is called a neighboring position. And a neighboring position on a grid is very easy to find. Okay, like 1, 2, 3, 4, 5 neighbors. But when you're here, you will move by, I don't know much. I don't know how much. And if you decide to move by this, then you're going to miss position. You're going not to try all of the positions, which means that in some cases, your pathfinding system, in this case, is going to say there is no path between A and B, while there is one. So you will never find a path that isn't there, but sometimes you will miss existing paths. And this is a big problem, because if you have a robot that is behind a wall and wants to get to you, and it looks for a path, there is one and it doesn't find it, then the player is going to see that something is not correct. So So this is why using a continuous coordinate system was not the best of ideas. The reason why we did it was, I think, what is a very common mistake in open source game development. We thought it would give more power to the map makers, and so naturally, if it gives more power, it's better. And this is completely wrong. This is true if it doesn't cost you anymore. But when you end up in this kind of situation and you notice that, one, the additional power was not used at all, and two, you have had bugs. So for example, for 5 years we had bots running through walls because of the incorrect collision detection. The collision detection that was originally implemented was a step-by-step system. If you do step-by-step system on this, if the wall here is not large enough, you're going to step right over it and you're not going to see that there's a collision. It's stupid, but it worked like this for a few years. So in the end, not a good decision at all. And if you only look at, okay, this looks cool, and you do it without thinking about the costs, not a good decision.
Just wanted to comment. There is a nice middle ground between the two approaches, where you have floating point coordinates for the actors, but the map is a grid.
Yes, yes. I'm not trying to redesign for the RPG. I mean, we cannot change it. The point where we're at, we cannot change it. For the sake of the presentation, I wanted a simple way of explaining collision detection. Obviously, there are many ways of doing it. But this one is wrong. This is my point. Okay, so it resembles the collision detection problem. We have a way when your player is in a cave to present some lighting like this. It feels much more oppressing. You don't see around you. So this is a very important point for... actually, you probably don't see much. This is a very important point for gameplay because the point is that you do not see much. This is really what it was made for.
We see that we don't see much.
Okay. Well, so the way we do it is we first render it like this, and then we draw kind of a gray mask which is lighter here and darker here, and we draw it on top. And the way we compute the values of the gray mask is based makes very easy use of the collision detection system, which, as I've said, works with continuous coordinates. So this is a lot of vector mass. This is a lot of floating point vector mass. This is a performance killer. This is really a performance killer, and it matters a lot because well, this is a dual-core laptop, so it goes fine. But on the small EPC things, you basically cannot play with the lighting because it costs so much. Because we do a lot of we throw rays and we check if we hit walls. And if we throw many rays, it costs a lot. But if we throw too few rays, it's going to look very ugly. So the lighting algorithm kind of results from the continuous system that we use. It's very poor. But it does look good. So unlike the other, which was really a problem in terms of what the players actually saw, because they saw that bots were going through walls, they saw that some paths were not found. Here the players do not see it. But if they touch the laptop and see that it's getting very hot, now they kind of notice the problem with the lighting. And finally, this is a real-time application for most of it, except the dialogue part. This is a real-time application. It's rather difficult to test automatically. And here we made another wrong decision, which is exactly the opposite as the other one. We said, okay, it looks difficult, let's not do it. Again, not a very good decision because we had a previous talk which talked about the fact that when you release a beta release, people take it like it's the new version. So either they don't test it at all, or they get it like it's the official new version. And we made a 0.15 release a few months ago. We released beta versions. People did not test it, and then a few days ago, just right when I was preparing my presentation, I got a message that we were corrupting the save games in some cases, which breaks the game of the player. So for us, it's a very, very big issue. And we got that because we didn't see the regression. And we did not see it, one, because the players did not test it, but it's a bit easy for me to accuse the players of not testing my software. And we did not see it because we didn't have the automated ways of seeing it. Could we have done it? I'm not sure, but what I know is that we haven't even tried. So automated testing, it's very annoying, but sometimes I think you can't avoid it. Now, we have a few remaining questions in Frigid RPG, which are the things that we have not solved and we do not know how to solve them. The first one is translations. The second one is save game compatibility. The third one is level editor. So I've got a bit more time, so I guess I can go into details. The issue with translations is that we have a lot of strings. We really have a lot of strings because this is a game where you read, this is a game where you write. A few years ago, we decided to use getText, and by then there was not this web application called Transifex, I think. It didn't exist by then, so it was a bit more difficult to translate getText-based stuff because I, as a project leader, if I start translating strings, I don't do anything else, and it's not good for the game. So we really have to get other people to do it, especially since my German is sehr schlecht, and I cannot translate the game to anything else than French. So you really need new people to do the translations. So you have to find a way to make it easy for them to translate your game, and also make it easy for you in terms of maintenance. And if you keep modifying the dialogues all the time, you can't do the translations. Now, I think we're much more stable, but still, on a technical point of view, we didn't have a very positive experience with getText. And at the moment, we really don't know how to do it. We know we want it, but we do need a translation team, and we don't have one, and we don't really know what is the best technical solution. Also we had another problem. Our font engine was ASCII only. So that's good for English, English, and English. So this was and I solved it. I said, okay, let's use ISO 8859. So this works for French, German, Italian, and that's about it.
English.
And English, yeah, English. So when we had the translation team of 5 Russian people, I told them, okay, you draw all the fonts and we'll see what we can do. And they left. So yeah, I don't like Unicode, but when you do translations, you don't have a choice. Another problem that we have is wasn't 2100 does it. So when they release a new version, when we release a new version, we break save game compatibility. So you start playing on 0.14, we release 0.15, it's much better, we tell you to use it, we want you to use the last version of the software, then you try to load your game and we say, oh, no. This is very, very frustrating to the potential players. And we know it. But it's also very difficult for us, because it's a lot of additional work to properly handle save game compatibility, especially when you really change the data structures, when you add a new quest between 2 quests. If you load the game which is at the first quest, what do you do, and so on. So we've got a lot of questions about this. And right now we haven't planned on handling this, but we know we will need to do it for 1.0, because right now it cannot work. And finally, sorry.
Well, you don't have to have compatibility. You don't have to have compatibility. You don't want to. You want to have a converter. Because then you're safe. Just have a converter convert the side games. The old engine loads the old games, the new engine loads the new side games, and you don't have to keep compatibility.
Yeah, but in terms of concepts, I consider a converter to be the same thing as handling compatibility. You don't have to have full compatibility, but even a converter, it's not always easy to write. Because if you changed some basic structures of the virtual world, I'm not speaking about adding a field, I'm speaking about really changing the story. What do you do? Do you play the old or the new story? And how do you integrate the old story into the new one? You can't. So you have to play the old story, and you don't want your players to play the old story. That's kind of the point. So this is a bit difficult for us. Yes, the last question that we have, this one is much more advanced. Translation and save game compatibility, we really don't know how to do them, but the level editor is something else. We have had, forever, an integrated level editor into the game. Now, the problem with the level editor is that, conceptually, it's here to create, delete, move, and so on, any kind of objects. So inherently, it will do a lot of modifications to the data structures of the game. It will create, it will move, it will do a lot of things which the game doesn't do. So the data structures that you use, for example, to optimize your collision detection, because it's very costly in future RPG, you use the data structures that is appropriate for the game, but you find out when writing the level editor that, oh, you can't move obstacles with the data structure that you've chosen. So the difficulty with the level editor is that you optimize, you build your game, you optimize for the engine, and then you notice that you have to build something on top of it that enables the user to make a lot of changes to something that you had not planned in the engine to be changed. So I don't know if I'm making myself clear. We have a technical issue with the data structures, and we have also a user interface issue. Because if you think about it, you say, okay, using the game engine to implement the level editor, this is a good idea. And in fact, you will notice that what you do in the level editor has nothing to do with a real-time game. And I can actually show it to you, because I've got time, yeah. So the game, you've seen it. Okay, so here I can move around. Okay, now let's get into the level editor. The level editor works quite differently. I don't have a player, I don't make him move, and I can do a lot of things. For example, I can select, and then I can drag and drop. Okay, oh, here you see the floating point coordinates for obstacles, which means that the alignment is really, really tough to get correctly. So we had to implement a system in the level editor that forces the alignment because the engine doesn't. So anyway, after that I noticed that there were a lot of ready-made tile editors, which are, there's one called TileED, I think, and even the ones used by games, by other games. But we could probably spend much less time trying to use external editors than write one, especially since this is a development tool, so it doesn't get much love, because if I spend a second on this, I'm not spending a second on the game, and if I do not spend a second on the game, I'm not making the game better for my audience. So this is a difficulty, because this is a waste of time. Working on the level editor is a waste of time. In terms of talking to your audience, it is a waste of time. But on the other hand, if you do not improve it, people will not use it. And also I thought, because 4 years ago I said, okay, let's improve it, people will use it. No, it doesn't work. You don't get people to use your level editor just because you've made it better. You need to make it good. And we're very far from it. I can try to design a small room to show you, but it's much better than it was, but it's still a pain. Okay, so here you can see I'm placing obstacles, and here you will see the different kinds of elements which I presented earlier. Here you see them pretty clearly because I can select them. Here you have the obstacles, you have the floor, then you have the actors, which are enemies, but yeah, okay, it works. And you have other kinds of, the dropped items and so on. So yeah, the level editor was another point that is still a question for us. And if I'm not mistaken, I have a few minutes left for questions.
You do.
Excellent.
I have a, well, you said at the beginning that your audience is supposed to be both adults and children, so that you made the game complicated to appeal to adults, but made the graphics not well, very colorful and simplified to appeal to children. Are you sure you can actually reconcile those two approaches?
Yeah.
I mean,
we have a rather significant audience, and we have a lot of people telling us that they like the game. So there is definitely a group of people who like this, and for what it's worth, so do I. I don't think that you need to have. This is an apocalyptic world. When you look at it in the game, it doesn't look like it. As far as I am concerned, I think that Fallout kind of covered the world of realistic apocalypse. And okay, this is done now. Let's try to do something else. And yeah, I know that if you find that the graphics are lame, well, I'm sorry that you don't like the game, but I know, but
special.
Yeah, it's a choice. Really, it's a choice. And we have had a few parents coming on the RFC channel saying, "Oh, I'm playing this game with my kid. This is the first time I'm playing a video game with my kid." So yeah, it's interesting to hear. So.
I see.
Now, the real difficulty here is that the dialogues are fairly complex. And especially since most children in the world do not speak English, they cannot play through the RPG, so this is very difficult for us. Our English is of educational quality. We do spend a lot of time trying to make it really good, so no bad words, but especially we concentrate on having good grammar, so really you can use it to teach English.
British or American?
American. We have lots of contributors writing British English, and then I go after them to tell them this is American English.
Make a translation for British.
Oh.
We do so at Westmont.
Yeah, but you've got perhaps 15 times more resources than we do.
Yes.
Also a point, I just thought about it. You have difficulty attracting people who would make maps and who
Oh yeah,
translate.
there's one thing I forgot to mention. We noticed that we had difficulty attracting people to make maps. So one day I woke up and said, hey, that's easy, let's write a random level generator. So we wrote one, and it's actually not too bad. We had a Summer of Code project on it. I actually managed, when I was at school, to have that as a school project too. So we wrote a random level generator, which makes it very easy, because once you write the code, and I'm not a good map designer, but I can code pretty quickly. Once the code is written, you can generate a lot of levels. So does that perhaps answer?
No, I was thinking about maybe the audience that you are aiming at is not the audience that would like to contribute to your game.
We have a lot of people coming on the channel saying, hey, I would like to contribute. We managed to retain about 1% of them. Sometimes they can't write correctly. Sometimes, well, it's very difficult because we do attract a lot of rather young people. And I don't want to pick on my own age group, but they lack the ability to commit, really. They imagine that it's going to be very easy, and then they see that game development is difficult. And well, I think this is a big thing, because everyone thinks that writing a video game is easy, and actually no. And I think this is the main reason why we lose a lot of potential contributors. I don't think it has to do with us. The main reason, I mean, now we do lose a few people because of the management style. We have very few resources, so I am the person who approves the patches, and well, sometimes it doesn't go well, but mainly I think the issue is that we have...
How old are you?
I'm 23.
You think that it's still too young for being an excellent game?
For being, I'm sorry?
A good game.
You should speak louder.
You think 23, I understood
Yeah.
correctly, is too young to be an excellent game code?
No, that's not what I said. What I said is that most of the people that we get that tell us that they want to contribute are 15 and have never written a single line of code. This is what I said. The fact that they are 15 is irrelevant, except for the fact that perhaps they lack a bit of the maturity to realize that all things in life are not easy. I think they really underestimate the difficulty. Now, is this tied to the edge or not? I don't know, but...
Would it maybe be a possible approach for you to go the other way of allowing them to design scenarios?
Yeah.
So that they don't start with hardcore coding,
Yeah,
but
we try...
work via producing some content first, since the basic steps are often rather similar.
But this is what we need also. I don't want code. As a project leader, I don't really care for contributions. Our engine is done. We need content. So we try to encourage people to write content, but it's difficult to produce very good content. You have to have good English, you have to integrate into the general environment of the game. Just not so easy.
I will just ask for a translation issue. I know that there is some project who used Transifex,
Yeah.
and which each work pretty well to get some people involved, because it's centralized a lot of open source project. Have you tried to use it?
We used a Launchpad. We gave up because it was not good. Then Transifex came along, and a separate team from Huillet RPG, an unofficial translation team, started to use it. And the problem that we have is that in English, when you say you, it means you singular or plural. but in French you have tu, you have vous in Deutsch, and so on. So the problem is that when you have people like this, when you have 20 people contributing translations, if they do 1 or 2 strings each, the result is terrible.
And are you planning to do a multiplayer mod or something like that?
This is not this is not the goal for the project. So once we release 1.0, perhaps we'll do it. But really, it's another world. It's completely different, and I'm not personally interested in it, and most of the team isn't. So, single-player game.
I would like to know how do you think to attract people to play the games? Because usually there are much more other kind of games which are usually played by people like strategic first-person shooter or role-playing game. So I would like to know why do you think Amen or Skype or people should never play your game?
Why do I think someone should play your game? Because it's good?
Make it 1,4 by 7.
No, I'm sorry, I didn't quite get this question.
Quite sure to work.
I mean, why someone should play your game instead of another? What do you have better than another game?
If you look at
They can continue
the whole world of free software games, we actually are playable. This is the first thing, because there are a lot of open source games out there.